It's built in. That's our secret sauce right there, the ability to work on long, low-grade cables, low-grade connectors at very, very high bandwidths in a very, very harsh electromagnetic environment, and to guarantee that what comes out of our chip is flawless. And I'm talking about literally flawless.
Hello IPX, we are yet again at CES and we're going to now be talking about cables. You're asking me, what's disruptive about cables? Well, what's disruptive about cables is the data that runs along them, how efficient it is, the type of cable you can use, and the amount of cable you can use is all about the problem that Valens
absolutely
solves.
We come along to solve that. We're a disruptive
So
technology.
welcome to Daniel from Valens.
Thank you, nice
which
to
is
be
a disruptive
here,
company that I haven't come across, but he's going to explain to you what they do. Over to you, Daniel.
Perfect. So Valens is a fabulous semiconductor company with a focus on high-performance wired connectivity solutions. So it's all about what you said. It's about reducing the amount of cables in the vehicle. It's about reducing the quality of the cables and the connectors. And we can actually squeeze a whole lot of bandwidth from very, very simple cables. They can run very, very long distances as well, bringing clear cost benefits and performance benefits to the tier ones and ultimately, of course, to the OEMs who are implementing our chipsets in their system. But actually, we began in a completely different market. We were established in 2006 with a focus on connectivity solutions for the audio-video, professional audio-video market.
Okay.
And our technology allowed us to converge HDMI and USB and controls and power and even Ethernet all over one.
Could you show a little bit more passion?
I can try.
Go on, go on.
Our technology allowed us to provide an incredible amount of bandwidth for convergence
That's
of
better. You're putting real passion into
multiple
this now.
data types.
Good, excellent.
Over one very long reach cable.
Okay.
And that was unheard of in the industry. We brought to the professional audio video industry a really revolutionary, disruptive technology that enabled the installers to do something they'd never been able to do before.
Right.
Fast forward a few years from 2006.
Very specialist market.
It is a specialist market.
That bit was
absolutely
entirely specialist.
Exactly. We've branched out in that particular market into new segments.
Quality was absolutely paramount.
Professional audio video quality is number one. Okay, you do not get any compromises on quality in Pro AV.
So heritage in understanding how you take whatever that information is and deliver it in the highest quality way.
Absolutely,
okay.
Without any compromises. Okay,
Excellent.
And that's why we are the premier. My teeth are falling out. The premier supplier into that market. We formed an alliance with more than 200 member companies, all of whom are selling our chipsets in their products to an entire range of verticals within that industry.
Okay.
An amazing technology. Now, fast forward about 8 years from that early days of 2006. The automotive industry was facing exactly the same problems as the Pro AV industry. In other words, they had too many cables in the wire harnesses, right? Wire harnesses are notoriously complex, they are heavy, they are expensive to manufacture, and if you have a vehicle on the road and your harness goes wrong, the vehicle is almost unusable, it's almost unrepairable, right? And actually, we were approached by a leading premium German OEM who said, could you do what you're doing in Pro AV, but now in automotive? And I was, give us a solution that converges different data types on a very high quality data link.
So at this point, that's all data.
That's all data. It was 1 gig Ethernet. They wanted USB 2.0. They wanted digital audio, and they wanted control protocols. Now, before
this is 2006. This is a long time.
No. This was automotive. We were talking about around 2012, 2013.
Yeah, still in real times.
Eons ago.
That's dinosaur world.
I had hair on my head back then. That's how long ago it was. And so they approached us and said, can you do it? You're doing it in Pro AV. What about in automotive? And we said, well, of course we can. Okay? And we created a technology which allows us to run over a single unshielded twisted pair, one UTP cable. We pass, as I've said, 1 gig Ethernet, USB 2.0, digital audio and controls, and we can even deliver power over that cable as well. One cable, one connector at each end that can run up to 15 meters long, and we can have up to 4 inlines in the middle. Now, that solution, if you think about it, means that now I don't need one cable for my Ethernet, one cable for my USB, another cable for my audio, another cable for my controls. I'm reducing the complexity, the cost, the weight of the harness.
So if you didn't exist, it's 4 sets of cables.
It's 4 sets of cables and maybe even more. And some of those legacy, shall we say, those, for example, USB 2.0 by spec can only run up to 5 meters. That's not enough in the vehicle. We can run up to 15 meters, so it's not just about the convergence, it's also about taking things longer distances than they were originally designed for. That premium German OEM is Mercedes-Benz, and for more than 3 years now, we have been the wired connectivity solution that connects the different elements of their amazing, I don't know if you've ever seen their amazing MBUX, the Mercedes-Benz user experience. It's their infotainment system. It is incredible. And that system is powered by Valens chipsets.
Right.
And so we're very, very proud of that achievement in transitioning not just to be a professional audio video, but becoming a quality supplier to the automotive industry in a very, very short period of time. Now, I'm standing here in front of a wall that has MIPI Alliance written on it, and you may be saying, just a minute, where does this feature in?
Well, I don't actually know what the MIPI Alliance is. So, so yes, I am. I am mysteriously looking at that, going, I wonder what that is.
So we really are going to...
Not all our community members won't automatically recognise what that is. So can you explain that?
Okay, let's start with the MIPI Alliance. Yeah. Okay, MIPI stands for Mobile Industry Peripheral Interfaces. Okay, the MIPI Alliance was, where's that? I pull out a prop. We all have one of these. The MIPI Alliance put together specifications and standards, things like camera connectivity within our cell phones, CSI, camera stream interfaces, a protocol to transfer from the camera to this processor, DSI from the processor to the display. So MIPI originally started off in the cell phone world.
Right.
Okay,
so that's the standard protocol.
Yeah, it's a standardization body that originally was producing standard solutions for cell phones.
Got you. Now, I know what that means.
So that's MIPI Alliance. Today they boast more than 400 member companies. They're a huge standardization body. Now, what was happening in the automotive industry was those CSI and DSI solutions were being put into vehicles because, as you know, we're transitioning to more and more cameras, more and more displays.
Cars are just devices on wheels.
Mobile phone on wheels, more or less, right?
Yeah.
So basically, the cameras were going into the cars, the displays were going into the cars, but as I just said, MIPI stands for, the M in MIPI is mobile, where the distances involved are centimeters.
Yes.
In the car, the distances involved are meters. And quite a lot of meters, and ever increasing numbers of meters as the vehicles get bigger. So the question is, how do you get a protocol that's intended for just a few centimeters of distance over long distances? And what happened was, to fill that gap in the market, the SerDes, serializer, deserializer technologies came along to extend a few centimeters to several meters. Now, those technologies are analog technologies, and not only that, but they are proprietary analog technologies. When I say proprietary, I mean that they are sourced from a single company. There are two main players. You either buy from this one or you buy from that one. They are non-interoperable solutions, which means that if you can't get the chipset from him, you can't just go to that one and plug it in. It's not going to work. Completely different technologies. Now, as we all know, the supply chain crisis of the last few years that hit the automotive industry so hard, if you want to say two dirty words to an OEM, it's proprietary, single-sourced. That's three dirty words, actually, but you know what I mean.
Yep.
And so
they never worried about that before the pandemic.
Because everything was fine. Yep. Everything was fine. And now they face the crisis. The MIPI Alliance came along and said, well, hang about a second, CSI and DSI, that's our technology. So why don't we now do a physical layer spec that allows us to run those technologies over much longer cable distances, which the proprietary solutions were doing, but they were doing it in not the greatest of ways. They were analog technologies. The MIPI Alliance said, let's see if we can do it better. And they put together a call for companies to join a working group for what they were calling A-PHY, MIPI A-PHY. And Valens went along and we proposed the same technology that's been on the road with Mercedes. Now we proposed that technology to the MIPI Alliance. And many other companies came along and proposed their tech. And after, I'm not sure if it was a year, maybe a little bit more, maybe a little bit less, but after around about a year of this debate and discussions and lab testing and analysis, the MIPI Alliance, this kind of working group, fell into two camps. One camp said the Valens way is the best way. The other camp said, let's do it in a way that uses technologies that are things like forward error correction, okay? And that was the split. And ultimately, after reviewing all of the data, the MIPI Alliance Board of Directors decided that the Valens approach was the right way to go for automotive applications. And so our technology forms the basis for the MIPI A-PHY specification, okay? Right. That's why we're the first in the industry to bring product to market, chipsets supporting this great new technology. And in fact, so good is MIPI A-PHY that just a few weeks after the launch of Spec 1.0, the IEEE, of course, another huge standardization body, decided that through their industry affiliate network program, they were going to adopt MIPI A-PHY as a standard of their own. Right. So it's not just a MIPI standard, it's now an IEEE standard, 2977-2021, if I'm not mistaken.
I don't know whether you're mistaken.
Nor do I, but I'm sure somebody over there is going to be watching this and we're going to be Googling IEEE A-PHY and they're going to be sending me hate mails after this.
Yeah. Don't ask, okay?
Don't ask,
take it that it's fine.
2977, take my word for it.
Yeah.
Basically, we now have an ecosystem of companies who have access to the market, to A-PHY technology that is 400 plus members of MIPI, hundreds and hundreds of member companies of the IEEE.
Right.
That is a huge ecosystem.
So let's just backtrack.
Sure.
You started in audio.
Yes, audio, video, yes.
Audio, video. You need really clear, very high quality ability to move data over a small distance.
No, over a long distance, 100 meters,
sorry.
Beyond...
Forgive me, I'm just trying to summarise.
Over 100 meters.
You understood how to move data.
Yes, sir.
And high quality data.
We do.
Right?
Yes.
Somebody comes along to you and says, can you take that knowledge and stick it in my car?
Yes.
Yes?
Absolutely.
Then cars then become devices on wheels.
Right.
And somebody says, we need to have a standard to enable all the data in the car to be moving around so that we can all do it together.
Absolutely.
Which was the standard that started in the mobile phone. So you were centimetre.
Yeah, exactly.
0.1s of centimetres.
Exactly.
With the data movement.
Exactly.
So you've gone from the heritage of audiovisual, understanding how to move that and how to have chips that do that. Then someone comes along and says, how do you do that in a car? You solve that problem in a car. The car then becomes a device, which it is because of everything.
Of course.
That's just going to, forgive the pun, but accelerate.
Nicely done, sir.
Yes. So now you're at the heart of the absolute standard of how you move data through cables, whatever they are.
Indeed.
Because you're clever.
Yes, sir.
All around the car.
Exactly.
And that's what you do.
And that is what we do. That is our key technology strength is in the physical layer. In other words, that's the way we drive data into the cable and we recover data from the cable, okay? We are a digital technology. It doesn't matter if we're talking about the audio-video offering, our first generation of automotive, or now the MIPI A-PHY standard. We have hardwired DSP algorithms in the receiver that enable us to do things like noise cancellation. So in other words, if we think about it, and let's just maybe take a little look at what's happening in the industry before I go into that. We see a lot more sensors going into the car. The MIPI A-PHY standard is designed for sensor connectivity or for display connectivity and for display connectivity.
Yep.
Our first offering of chipsets is focusing sensor connectivity. And if we just need to see how many more cameras, radars, and now LiDARs are going into the vehicles, right?
CES.
Exactly. You walk around the show floor here, you will be hard-pressed to find any vehicle that doesn't have probably at least 6, 7, 8 cameras and probably 3 or 4 radars in it. We begin to see LiDARs being deployed. These are mission-critical systems, right? The car, of course, we're reaching a transition point when it's a little bit difficult to know, am I driving the car or is it driving me? And we're putting our faith into data links that if they go wrong,
We have a problem.
We do have a problem. Houston, we have a very, very big problem. I mean, these are not cameras that we're using in the car in order to do our hair. You and I obviously suffer from the same needs for our hair care.
I have a great hat on, thank you.
Thank you very much. So these are mission critical systems, right? And if that link fails for whatever purpose, we find ourselves in a big problem.
Yeah.
So we see a need for very, very robust links, in particular given the fact not only are they mission critical, but the automotive EMC environment, electromagnetic environment, is one of the harshest there is on the planet, if not the harshest. We have electric motors spewing out noise. We have spark plugs spewing out noise. We are in an electromagnetic, that's hard to say on day 3 of the show, electromagnetic environment, which is changing all the time. We drive along, there's a cell phone antenna, there's a motorbike drives past us.
Just NFC.
Yeah, absolutely. And there's a whole load of near-field interferences, and we need to be able to deal with those and guarantee that the link quality remains absolutely perfect.
Integrity,
signal integrity, and we do that in a digital way.
Right.
So in other words, as I kept saying, we're a digital technology that employs DSP mechanisms like adaptive noise cancellation, like physical air retransmission for error correction, like adaptive equalization to guarantee that the data that is flowing across the link is received successfully.
Right. So this has ended up being a really good, interesting introduction to Valens, which you've explained how you're disruptive and how you bought it from other technologies. Just to finish off, before we do another video and we look at maybe some application examples as how you solve problems. There's a lot of stuff in there that our community would think I'd have to go to a specialist for. Noise cancellation, for instance.
Yeah.
And you're saying we don't need to do that.
Yeah.
It's on our chip.
It's built in. That's our secret sauce right there, the ability to work on long, low-grade cables, low-grade connectors at very, very high bandwidths in a very, very harsh electromagnetic environment, and to guarantee that what comes out of our chip is flawless. And I'm talking about literally flawless. MIPI A-PHY has a packet error rate of 10 to the minus 19. That is like one packet error every, and I can't remember how many tens of thousands of years it is for typical use of the link. Okay, this is flawless data delivery. It's also high bandwidth. The spec defines up to 16 gigabits per second on one cable. Our first generation chipset runs up to 8 gigabits per second on one cable, with a link latency, in other words, the delay end to end across the link, of just a few microseconds. Okay. So good is our technology that let's say we're talking about a camera connected to a processing unit. So good is our tech that they do not know, that camera and that processor have no idea that we are sitting in the middle. We are a very smart, a very high performance, but a very transparent pipeline at the system level, offering fixed delay across the link, offering fixed data throughput across the link, irrespective of what the noise levels are in the vehicle, irrespective of what the environment the car is operating in. And that is a very, very unique value proposition that analog SerDes solutions on the road today simply cannot offer. They are limited in terms of the bandwidth, they are limited in terms of the types of cable they use. We can actually run up to 4 gigabits per second with A-PHY technology over an unshielded cable. No other SerDes technology can run unshielded, they have to use shielding. So again, we offer the maximum performance from the cheapest cabling that you can imagine.
Daniel, I can't take any more.
I can give you a lot more.
No. The enthusiasm and the data that's coming, literally, the data that's coming.
Nicely done.
Yeah, too much now. I'm done. That's a brilliant introduction for our community. I think what we're going to do now is we'll do a few demos, look at some stuff in action. So follow those videos and we'll go from there. But for now, thank you for that introduction.
A very great pleasure. Thank you.
So that was Guy's interview with Valens from CES 2024. Very cool company. Obviously, I was kind of a little bit giddy after hearing that they started in pro audio visual technology, but expanding extremely simplified wired communication to automotive devices seems like a no-brainer, especially with how complex cars are getting these days. So learn more about Valens' solution on the ipXchange website and look forward to a couple of demos that will be coming soon. Keep designing.